Hello, we're on 6.03 for Pre Calc today, and we're going to talk some more about vectors. We're going to do linear combinations and angles. All right, so standard, that's kind of straight. Okay, standard unit vectors. So a unit vector we talked about before is just a vector that has a magnitude of 1 or a length of 1. So we're going to name these two vectors I. Vector I is 1, 0, and vector j. And we can call these, we call it with like hat, I hat, j hat, the 0, 1 to show it's a vector. So if we were to plot these out, we'd have, again, they're in component form, which means their initial point is at 0, 0, terminal point is at 1, 0. So if I go over here to 1, 0, this right here, and show you in green so you can see a little clearer, that is going to be vector I then. And if I go to the point 0, 1, that's going to be vector j. All right, these vectors can be used to represent any vector. So this is where our linear combination comes from these unit vectors. So this part here is your horizontal component, and this part is going to be your vertical component, since that's the vertical line. So if I wanted to write vector v, which in component form is v sub 1 comma v sub 2, if I wanted to write that as a linear combination using these unit vectors, I could write it as v sub 1 I plus v sub 2 j. So really all you're doing is you're putting an I next to whatever comes first, the first component, and a j with the second part. And instead of a comma, it's a plus sign, and there's no angled brackets anymore. So it's the same, those are two equivalent. So try another one. Let's talk about vector u is 3, 4. So think about how you could write that then using I and j. So writing it as a linear combination as opposed to component form. So as a linear combination, it would be 3i plus 4j. So these are your linear combinations. So let's talk a little bit more about the linear combinations. So let's say writing a linear combination. All right, number 1. Let u be the vector with an initial point at 2, -5, and a terminal point, so the ending point, is at -1, 3. Write u as a linear, so vector u, as a linear combination of the standard unit vectors, meaning I and j. and then graph the vectors as well. All right, so first, let's write it in component form. And then we're just going to switch it like we did in the examples up here. After we get it into component form, we can easily write it as a linear combination by just making it addition and adding your I and your j in. So again, for component form, you're going to always take your terminal minus initial. Okay, so we're going to take angled brackets, vector u equals our terminal here, and here's our initial right here. So we're going to do -1 minus 2 and 3 minus -5. So that gives us -3, 8. So that's in component form. So to write it as a linear combination, all we do, take off our angled brackets, make it -3i plus 8j. So no comma, plus instead. And this is your linear combination. All right, and then it asked us to graph. So I'll draw some axes on here. All right, so if I'm graphing this, then I'd be graphing the point, its initial point is 0, 0, and the terminal point is -3, 8. So -3, we're going to be off here a little bit. 1, 2, 3, 4, 5, 6, 7, 8. Actually, maybe I'll just count by twos then. So it's not up through our words. So 0, 0, and then -3, 8. And again, we can show that if we graphed our initial point, which was 2, -5, so this has to still count by twos, so we'll go 2, -5, and -1, 3. You can see it continues there. And so they're in the same direction. They have the same length. And so they're equivalent vectors. This black one, I don't know if you can see the difference, but this black one here is in component form. And then the purple one is using the initial and the terminal point to graph it, but they are equivalent. They have the same distance and length. Same with these two in component form here, and linear combination would have the same distance and the same direction. All right, let's try another question. Let u be -3i plus 8j. Oh, so you can't see, sorry about that. And v equals 2i minus j. Find tu minus 3v. Okay, so there's two different ways you could do this. Because they're given as a linear combination, I do want your final answer to be as linear combination. You can keep it as linear combinations, or if it's easier for you to use component form, that's fine too. I'll show you first using a linear combination. So 2u minus 3v. So we just take 2 times -3i plus 8j minus 3 times 2i minus j. And here then you could just distribute. So your scalar multiplication would give you -6i plus 16j minus 6i plus 3j And then you would just combine your like terms. So negative 12i plus 19j would be your final answer. Now you also could have done it where you change them to component form first. So you could have said u is negative 3, 8, and v is 2, negative 1. So just taking your coefficients, sorry, you couldn't see that, 2, negative 1, negative 3, 8, and then did what we did last class where you could just multiply 2 times negative 3, 8 minus 3 times 2, negative 1. Again, just distributing, and you'd get that same answer. I can show you here just in case you're unsure. So I get that vector. Now here, be really careful, because if you're distributing the negative 3, then it's going to change to addition right here. If you keep it subtraction, then you would have 6 and negative 3 in there. So be aware of whether or not you're distributing that negative or keeping it. So I'm going to distribute the negative 3 to get negative 6 and positive 3. And now when I add in component form, I'd get negative 6 minus 6, give me negative 12. 16 plus 3 gives us 19. And then what you could do is rewrite it as your linear combination. It's actually a little faster just to keep it in as your linear combination, but important to know how to switch back and forth between the two. All right, a little bit more writing we're going to have here. So we're going to talk next about direction angles. So that just means finding the direction of a given vector. And this is what you would do if you're given just one vector and asked to find the direction of it. We will be talking about finding the angle between two vectors, and that's if you're given two different vectors. So if u is a unit vector, meaning it has a magnitude of 1, so if it's a unit vector, such that theta is the angle measured counterclockwise from the x-axis to u, just like we would measure any other angle, like on our unit circle. The terminal point of u lies on the unit circle and you have u, vector u, is equal to, in component form, cosine theta, sine theta, which also is a linear combination, would be cosine theta I plus sine theta j hat, and that's a linear combination. All right, so that's your unit vector, is if you have cosine theta, sine theta. So the angle theta is the direction angle of vector u. So if you had your unit circle and u would be 1 here, here's your theta, this would be our circle. And if we had our right triangle, y would be your sine of theta, x would be your cosine theta. So our unit vector would have a magnitude of 1. If you look at your Pythagorean theorem, cosine squared plus sine squared would equal 1. Right. Thus, if vector v equals ai plus B times j hat is any vector with angle theta, then it must have the same direction as vector u and can be written as, I'll call this v equals the magnitude of v times cosine theta sine theta. That's in component form. So that's also the same thing as taking your magnitude times the cosine theta, magnitude times the sine of theta, because the magnitude of v is just a scalar quantity, so you could distribute it in, which is also the same as the magnitude times cosine theta I plus the magnitude of v times sine theta j. So that would be as a linear combination using your I and your j with addition. Therefore, the direction angle formula, which we're finally getting to here, is determined from tan theta equals sine theta over cosine theta, which we already know, which in this case now would be the magnitude times sine theta over the magnitude times cosine theta, which we're going to call b over a. So here this would be your a, and this would be your b. So this again is your a, and this is your b. So you're taking your second component here divided by your first. Okay. So now let's look at an example. Find the direction angle in degrees of vector u equals 3i plus 3j. And always with these, it's really important to draw a picture because that's going to show you what quadrant you're in, which you need to know in order to get the correct answer. All right, so to do this, you can start with the picture. And we'll have, so this is 3i plus 3j, which means in component form that would be 3, 3. So we're going over 3, up 3. So we're in quadrant 1. And we want to find the direction angle. So anytime it asks you to find the direction angle, your formula is going to be tan theta equals b over a. So the b comes from here, and the a comes from here. So we just take our b, which is 3, and our a, which is 3. And now we're going to do inverse tan of 1. So this first problem you should be able to do without a calculator. So inverse tan of 1. So you should know your sine and cosine. If you don't know them, you should draw them out here. So rad 3 over 2, 1/2, rad 2 over 2, rad 2 over 2, and 1/2 rad 3 over 2. So tan we know is sine over cosine. So if we divide each of these, remember you can ignore the 2's because they'll cancel out. Everything has a 2 in the bottom. So 1 divided by rad 3 is not 1. Rad 2 divided by rad 2, that is 1. So which angle is this? That's your 45 degrees. So we would say theta equals 45 degrees. Now, if this had been in a different quadrant besides quadrant 1, we'd need to put it in that quadrant using the reference angle. But in this case, it's in quadrant 1, so we're good with that answer. Let's try another one. So So find the direction angle in degrees again of vector u is 3i minus 4j. Make sure you draw a picture. And let's round to the nearest hundredth. All right, so let's start by sketching this out. So we're going to plot 3, negative 4, 1, 2, 3, 1, 2, 3, 4. So we are in quadrant 4. All right, so first though, we're going to need to find our reference angle. So first of all, we're asked for the direction angle. So we should be thinking formula is tan theta equals b over a. So I'm going to do tan theta equals, my b is negative 4, and my a is 3, so negative 4 over 3. And to find a missing angle, I do inverse tan. And this one, especially since it says to round to the nearest hundredth, we're going to go to our calculator. And I want to make sure I'm in degree mode here, which I am. If you're not, make sure you switch it. I'm going to hit second tan negative 4 over 3. And I'm going to write that answer out. Now, I want to put this into quadrant 4. So in order to do that, I need my reference angles. Remember, reference angles must be positive, and they must be acute and formed with the x-axis. So negative 53, that is an acute. It is acute. It is less than 90, but it's negative. So to make it positive, I just take away the negative. Now it's positive, acute, formed with the x-axis. So now I want to put that into quadrant 4 to find what that angle would be in standard form. So to do that, I'm just going to subtract my reference angle from 360. So I'm going to take, you can multiply it by negative 1, and then you could do 360 minus your answer, or you could have just done 360 plus that answer, and write out your whole decimal. And then round, it said to the nearest hundredth, so 2 decimal places. So 306.87 degrees would be your final answer. I can't tell you how many times students will give me the negative 53.13 answer and lose points here. We want this from, if it's a direction angle, we want it from 0 to 360. So you need to make sure you put it in the correct quadrant. So if it had been in quadrant 2, you'd find your reference angle and then do 180 minus your reference angle. If it's in quadrant 3, once you find your reference angle, you do 180 plus your reference angle. And then in quadrant 4, like we just did, 360 minus your reference angle. So actually, why don't you guys do one more on your own? So find, can't see what I'm writing, sorry, find the direction angle of vector u, negative 2i minus 6j. And round to the nearest thousandth, 3 decimal places. Okay, go ahead, pause the video and try this one right now. All right, so you should have graphed it out, seeing that it's in quadrant 3. You should have gotten tan theta to equal 3, so inverse tan should have given you 71.56505118, and that should be your reference angle. So in quadrant 3, we are going to do 180 plus your reference angle. So you should have gotten, write out your whole decimal, and rounded to the nearest thousandth would be 565. And you should have all of the work for that one, not just what I showed, but I should see your tan theta written out. So I know you didn't just copy what I just wrote there and that you actually did it on your own. All right, let's look at a couple more, but this time with our other parts of the formula. So not just finding the direction angle. So find the component form of vector v given its magnitude and you're given the angle it makes with the positive x-axis. So before, we haven't been given anywhere, we're actually given the direction angle. So suppose the magnitude of v is 3 rad 2, and your direction angle is 150 degrees. All right, so for vector v, if we're given the direction angle, that's when we need to use the formula that includes our angle. So we're going to take our magnitude times our cosine theta. So I'm going to write this on the outside. So our magnitude of v times cosine theta sine theta. All right, so we know the magnitude is 3 rad 2. Now we need to find the cosine. So we're finding the cosine of 150 and the sine of 150. So that's our theta. So again, you need to know this formula is new. This formula you're going to use whenever you're given the direction angle. Now this question could be asked on a no calculator portion here. So you would need to actually find the cosine of 150 degrees. So 150 degrees is in quadrant 2. So I want to find the cosine of 150. So I need to find my reference angle. 180 minus 150 is 30. Drop my perpendicular. I have a 30, 60, 90 triangle. Label it. Hypotenuse is always positive. And now I'm finding the cosine of 150, which is adjacent over hypotenuse. So adjacent is negative rad 3, hypotenuse is 2. And then opposite is 1, hypotenuse is 2. And now we're just going to distribute in our scalar of 3 rad 2. So we'd end up with rad 2 times rad 3. Those can be multiplied together to get rad 6. 3 times negative 1 is negative 3. This is over 1. So 1 times 2 is 2. And then 3 rad 2 times 1 is 3 rad 2. 1 times 2 is 2. And that would be in your exact value. All right, and number 7. Find the component form, so that means angled brackets with a comma, of vector v, given the magnitude is 3, and v is in the same direction as vector u, which is 3i plus 4j. So we've actually done this question already before. Number 7, we did this when we found the unit vector by finding the magnitude of this vector and then dividing it by its own magnitude and then multiplying that by our new magnitude that we want. So let's talk about a new way of doing it. So now we could also use our new formula here, the magnitude times cosine theta sine theta. Now here, I know that I need it to be in the same direction as vector u, which is 3i plus 4j. So I'm going to plot that vector over 3 up 4. And I'll just count by 2's here. So over 3 up 4. So this is a 3, this is a 4. So to find my hypotenuse, I could use Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. It's also Pythagorean triple, so you probably know that off the top of your head. Now here I want my new magnitude to be 3, so I could do 3 times the cosine of theta would be adjacent over hypotenuse. The sine of theta is opposite over hypotenuse, and then just distribute in. So 3 times 3 is 9/5. 3 times 4 is 12/5. Okay, so that way might be a little bit faster. I'm going to remind you of the other way we did it using the unit vector. So cosine theta, sine theta is your unit vector when you're using the angle, or here in this case, we could just graph it out to find the cosine and sine of theta. But we could also find our unit vector of 3, 4. So to do that, first you find the magnitude. So remember our magnitude of vector u, take the square root of a squared plus b squared. So that's 9 plus 16, or the square root of 25, which is 5. After you find the magnitude, then you can find the unit vector by taking your original vector of 3, 4 and dividing it by its own magnitude. So 3 over 5 and 4 over 5. That'll give you a magnitude of 1 for the vector 3/5, 4/5. And then you would multiply it by the new magnitude, which is 3. So you take 3, and here it should look pretty similar to where we were at on the left side, leaving us with 9 over 5 and 12 over 5. So this way is a little bit longer, but we've already been doing it that way. So if you're already comfortable with that, you can continue, or you can do it this way as well. So just showing you there's 2 ways of doing that same problem. All right, let's just do a couple practice for you guys. So we'll call this number 8. So find the vector v in the same direction of u, which is 2i plus 5j, with a magnitude of 2. Okay, pause the video and do this one. So you can do it using either of those methods that we just talked about. All right, so hopefully you found that unit vector. So you could have plotted out the point 2 over 5. This isn't drawn to scale here, but then you would have to do your Pythagorean theorem to find your missing side here. So 2 squared would be 4, and 25 would be the square root of 29. And then you could find your cosine theta and sine theta from there. So that would be using the magnitude of v times your cosine theta, sine theta. Or you could have done it using finding the unit vector and then multiplying your new magnitude by your unit vector. So that you would take 2, 5, find the magnitude, which again should be rad 29, divide that by rad 29, and then multiply through by your new magnitude of 2. Your final answer, which I should see all of your work for, and since it was given as a linear combination, initially I want you to give the answer as a linear combination. So it should be 4 rad 29 over 29i plus 10 rad 29 over 29j. And that's all rationalized, no radicals in the denominator either. And that would be your final answer. Again, I'm expecting to see more work on your papers for number 8. And then let's do one more. Find a vector in component form. So that's with the angled brackets, with a magnitude of 5 and a direction angle of 120 degrees. and leave your answer or put your answer in simplest radical form, SRS, simplest radical form. So this would be one that you should be able to do without a calculator. Okay, so you're given the direction angle and the magnitude. So this, if you need help, you should use number 7, I believe it. Oh, no, it was number 6. Use number 6 for help if you need it. All right, so you should have done that one out, and your final answer should be -5/2 and 5 rad 3/2. And again, I'm expecting you guys to have work for this when I look at your notes from after you've watched the video. All right, and that is it. If you do have any questions on anything, be sure to let me know. And I hope I see you all soon. I hope you're having a great day, and pie.